And now for something completely different. Imagine that the velocity in feet per second of a particle is given by this function here. And what we want to do is determine the average velocity on the interval from 3 to 6. Well, first let's look at the graph. Here's 3 right here, and so at 3 it has a velocity of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 6 here. At 6 it has a velocity of 1. A common mistake is to simply take the 10 and the 1, add them together, and then divide by 2. That would work just fine if we were looking at an interval on which the velocity was linear. But it's not linear here. So we have to take a slightly different approach. Average velocity is really found by taking how far you traveled and dividing by the time that it took you. If you drive for 2 hours and you travel 200 miles, then your average velocity is 200 divided by 2 is equal to 100. So what we need to do is on this interval, calculate the change in position. I'm not calling it distance because it can be negative. And divide that by the change in time. Frequently this will be written this way. 1 over change in time times the change in position. So let's talk about how we find this. Okay, well, the change in time is the easy part. We went from 3 to 6, so we would calculate that by taking the upper bound and subtracting the lower bound from it. The change in position at this point in the course is pretty easy for us to calculate too. If you've got a velocity function, then the accumulated change in position is going to be calculated by finding the area bounded between the curve and the x-axis. So this is going to be the definite integral from 3 to 6 of the velocity function. If you do the math, you find that this is 1 over 3, and this is equal to 21. Therefore, our average velocity is equal to 7 feet per second. Make sure that when you do one of these problems, you remember to put the units on it. Okay. In general, we have a formula for the average value of a function, not necessarily a velocity. And it's the same idea. If you want to find the average value of a function, all you need to do is take the integral of the function on that interval, we'll say from a to b in this case, and divide it by the width of the interval. Another way that we could write this is equal to 1 over b minus a times the integral and I'm going to come back to our problem here from a moment ago, and I'm going to mark the average velocity 1, 2, 3, 4, 5, 6, 7 right here. And I notice that we've got this point right here at which the function actually achieves its average velocity. And if you put this in your calculator, you put the function in and you put 7 in and you find where they intersect, you're going to find that it happens at 4.73. So there's the point that we're looking at. Well, what that means is that this rectangle that I just drew, it has a height of 7, it has a width of 6 minus 3. So this area should be equal to the blue area. Okay, so right here, orange area is equal to blue area. And so I'm going to note this in terms of the language of the problem. The orange area has a height of 7, and that's really the velocity at the point 4.73 multiplied by the change on the interval, which was 6 minus 3. And the blue area is the integral from 3 to 6 of the velocity function. Alright, well if we know that, then that brings us to the mean value theorem for integrals. And here's what the mean value theorem says. If f is a continuous function on an interval, then there's some point at which the function attains its average value. And we phrase that this way. F of c, that's like our v of 4.73 right here, times the width of the interval is going to be equal to the integral of the function on that interval. And usually what we're interested in doing here is finding what is this value.